Hello guys, time to talk about 6.2, multiplying polynomials, expressions, and functions. So let's get started. I'm outside today, so if you hear boats or noises or dogs, that's why I needed a little fresh air. Monomials, binomials, and trinomials. They're just exactly what you would expect: one term, two term, and three terms. Now, finding the product of two monomials means that you just need to multiply the numbers, the like variables, and you know that when you're multiplying like bases, you add the exponents. So nothing new here when you're doing monomials. When you multiply two polynomials, excuse me, such as x plus 4 times x plus 8, if you remember, some of you from high school, we called that FOIL, where you multiplied the first term, the outside terms, the inside terms, and the last terms. And then you can combine any like terms, such as 8x plus 4x. So that would be something of a review for you. So hopefully you can spend some time here looking at these for your homework. Now, when you multiply a binomial times a trinomial, you simply need to remember you have to multiply each term by each of the other terms. So this 2x has to multiply 5x squared, 2x has to multiply negative 3x, 2x has to multiply 4y squared, and the same with y. Y times 5x squared, y times a negative 3xy, and y times 4y squared. Then start cleaning them up and combine like terms. Now, multiplying trinomial times trinomial, just doing the exact same thing again. Start with an x squared, multiply it by every other term in the polynomial on the right. Then take negative 3x and multiply by all three terms in the parentheses on the right. Then take the 2 and multiply all three terms on the right. Now you're going to have a lot of like terms to go ahead and simplify, combine, and end up with your answer. When you're squaring a binomial, you simply can remember this formula, or you can always jump back to FOIL and make sure that you are all set. So it doesn't matter at all if you want to memorize this or if you would like to use FOIL. The biggest thing to remember that if you're using a binomial squared is you square the first term, it's 2 times the a and the b, and then it's b squared. And if you're subtracting, it's a squared minus 2ab plus b squared. So, again, I'm not going to spend much time on that because I don't believe in memorizing. So if that doesn't make sense to you, just simply keep foiling. And you can review these answers in your leisure. Now, if you have a perfect square trinomial, that is a trinomial that is the square of a binomial. And so let's look at this example of finding the product of two monomials. 4x cubed y squared times a negative 2xy to the 6th. You're going to multiply the 4 and the negative 2, the 2x terms, x cubed and x to the 1st, and you're going to multiply y squared and y to the 6th. With like bases, we add exponents. When you're multiplying binomials where there are conjugates, meaning one is addition and one is subtraction, you simply have to multiply the square of the first term and the square of the last, because in the middle will fall out. So if you're looking at these, number 1, x squared plus 6 times x minus 6, you square the first term, which is x squared, square 6, and you get 36. So that one will become x squared minus 36. And you can see as we continue through that these will all be the same. 9p squared minus 64q squared, 16m to the 4th minus 49r squared t squared, and lastly, x to the 4th minus 81. Writing a quadratic function in standard form. That means if you were given f of x equals negative 3 times the quantity x plus 4, quantity squared, plus 8, and you want to get that into a standard form, you simply have to multiply x minus 4 by itself to get the squared, take that answer, multiply it by a negative 3, and combine like terms until you're back to a negative 3x squared plus 24x minus 40. That is standard form. If you remember, it's ax squared plus bx plus c. You can also use your graphing calculator to verify your work. Now, let's talk about the product function. Yesterday, we talked about adding and subtracting functions. Today, we're going to talk about multiplying functions. When we multiply functions, we do just that. We're given two functions, 3x plus 7 and 5x minus 2. When we multiply them together, we use FOIL, and we end up with 15x squared plus 29x minus 14. If we're asked to evaluate that at 2, then we simply replace x with 2 and find that it's equal to 104. Now let's take a look at this equation and say what will happen if we want to evaluate the function of f as g of x. That means wherever there was an x, we simply have to replace g of x in there, and we do the multiplication. So if we had 3x plus 7 for the function of x, with f of x, and it says replace it with g of x, that means wherever the x was in the f of x function, you're going to put the 5x minus 2. So you multiply that by 3 and simplify. When you evaluate that at 2, you replace x with 2, and you end up with 31. Now, why might we want to do this? Well, we might want to do this by modeling a situation such as the annual costs in New York City prisons to be modeled by the function the cost of t equals 4.8t plus 77, and t is years since 2010. The average number of inmates in New York City prisons in thousands can be modeled by negative 0.42t plus 13.1, where t is the number of years since 2010. When you look at this chart, the table, you can see what's happening. The cost of dollars per inmate is increasing since 2010, and the number of inmates in thousands have actually decreased. So let's check out what these models look like, and if we multiply them, and when we actually do multiply them, what are we trying to find? When we check out these models, you can see that our equations do fit the data nicely. So if we multiply together the first function, c of t, and we multiply it to n of t, we end up getting c of t was thousands of dollars per inmate, and n of t is thousands of inmates. So now the units of expression are going to be millions of dollars, because thousands of dollars times thousands of dollars will give you millions of dollars. So we have to know that whatever our answer is going to be in millions of dollars. When we actually multiply those two equations out, let me get back to that, we end up with a negative 2.016t squared plus 30.54t plus 1008.7. So when we evaluate that at 11, we see that it's approximately $1,101 million. And that is 11 years since 2010 or in 2021. So this means that the total cost of New York City prisons will be about $1 billion in 2021, according to our model. And you can take a look at the graphs and check out what that means when you multiply the models as well. I hope 6.2 goes well for you. Keep working hard. I really appreciate it. I'll be in touch. Bye-bye.